for the last topic, we will still be talking about inverse functions, but with quadratic, cubic, and radical. So, essentially what we're just going to do is we'll just be talking about the radical examples. If you guys want examples for like the quadratic or cubic, let me know and I'll do it for you. But I just thought these were a bit tougher, so I thought I should talk about them. So before we get started with the examples, I want to make some remarks. So when you find the domain of a function under a radical, we have to find the values when x is greater than or equal to 0. Because if it's negative under the radical, then we're not given a real number. So like if I ask you what is the square root of -2, this is, we're calling this is I square root of 2, but this is not real. Okay, and when we talk about domain and range, they have to be real numbers. So, but when you have functions with an odd radical, so this works for the second root, fourth root, sixth root, eighth root, all the even roots. But when we talk about odd roots, like the odd radicals, we have no restrictions in the domain because they can have negatives under the radicals. Like for example, the square root of -8. This is -2 because -2 cubed is equal to -8. So they have no restrictions on its domain. So it's all real numbers. One last thing I want to mention. So remember when so the domain of f, it is also the range of f inverse, and then the range of f is the domain of f inverse, right? So why am I mentioning this? And before I continue, when we talk about domains and ranges, so I know in the last video I said sometimes finding range is not fun, and it's not. But you know what? We can still do it. We have the tools, all right? So we know that the domain is the x values. So what is the range? The range is our y values. So one thing when it comes to range, it's good to know what your graph looks like. So let's talk about the square root of x real fast. When I have the square root of x, so what is the parent function? The parent function, it looks like this, right? Yeah, so it looks a little bad. It's fine. But this is like, it's just generally what this looks like, all right? So as you can see, okay, the domain, so we know that x has to be greater than or equal to 0, and that's true because we only see the x values that go this way. But if you want to notice, also the y values, there's nothing below here. It's also up here. So the range y is greater than or equal to 0. All right. But now let's look at the cube root of x. So the cube root of x. Okay, let me try to draw it. So it kind of looks. Okay. So I know the cube root of x is the inverse of x cubed, and we know x cubed, like, look, oh, that's really bad. That's fine. You get the general shape. It looks kind of like a little snake, okay, or like a, yeah. Okay, so this is the inverse, what it looks like. So as you can see, we know that there's no restrictions on its domain because it goes from -infinity to infinity. We also, like, as we can see, since the arrows go, it's going to just keep going, like go up infinitely and then go to the go down infinitely. So also for the range of x cubed, it is all real numbers, right? And so is its domain. These are really good things to keep in mind, right? So these are the parent functions. So for example, if this changed, so since this is all real numbers, if you put any type of translation on it, it's not going to change its domain. However, when we have even roots, we do have to pay attention. So say like if it's +5, then it's going to go up 5 units, right? So then our domain, let me do it in blue, our domain, or sorry, not our domain, geez, our range, okay, would be y greater than or equal to 5, right? So keep in mind with all of these, I'm going to erase this. So if you want to copy this, you can just pause it and take a picture. right? But we gotta get rid of this, right? So why are we gonna do that? You will see in just a minute by when we start doing our examples. So for the first example, our directions for the examples is the functions defined below are one-to-one. Find the inverse of the function, then give the domain of the inverse using interval notation. So let's just go ahead and find the domain and the range of our g of x, right? So we know since this is a cube root, what does it tell us about our domain? It's going to be all real numbers. Okay, and then for range, because it is also a cube root, so it's stretched and it's down 4. However, the range does not change. Okay, it's still negative infinity to infinity. Okay, so we're going to keep that in mind once we find the inverse. So, and this is 1. So it's the same thing for radicals, linears, rationals. Doesn't matter. We're still going to use the same process to find the equation of an inverse function. So we have g of x. Okay, we want to find so we want to find g inverse of x. So how do we do that? This is going to be y is equal to the cube root of 5x minus 4. Let me make sure. Yeah, 5x minus 4. Okay. And then now we're going to interchange x and y. Okay, and we're going to solve for y. So remember, when we want to, when we have a radical under the variable that we want, we have to isolate it. So we're going to add 4 to both sides. Okay, and how do I get rid of this radical? So if I have the index is 3, that means I want to take the power 3 to both sides. Okay, the cubed. So we don't need to expand this out, all right? So just keep it as is, and this becomes 5y. So when I solve this, it becomes y is equal to x plus 4 cubed over 5, okay? And keep in mind, we are not done yet, because what are we looking for? We're looking for g inverse of x. We're not just looking for y. So we got to take that final step, and we got to say g inverse of x is equal to x plus 4 cubed over 5. All right. So now when I look at this, so even when I look at the range here, so we still got to check it over here, and we want to see 5 equals 0, okay, and never equals 0. So the domain is negative infinity to infinity. Okay, but essentially, actually, never mind. We don't have to look at this. That's fine. So what do we know about G inverse? G inverse has the same, its domain is the same as the range of our original G function. So the domain, because remember, we want to find the domain. So our domain is negative infinity to infinity. Right? So that is how you do the first example. And now I want to do a second example, this time with a square root. Okay, so one thing I want to say, so why didn't we look for the domain and range on section 2? So when it comes to linear, as long as like it's not rational or anything, we just need to for the domain and range of a linear function is always all real numbers, because this is linear. So for example, it's like y equals x. Okay, so it's a line, right? So domain will always be all real numbers, and range will always be all real numbers. So it's not really interesting. And I think that's why they didn't look for the domain and range. For a rational function, we know that it has to be when the denominator is equal to 0. So in this case, it's easier to find the domain of F inverse by just finding the domain, and then the range by finding the domain of F, right? So yeah, but for this one, for radicals, I always suggest always find the domains and ranges, because for a radical, like when you have an even root, you'll see it's gonna be something like this. So something's gonna get restricted, and it's just easier to find it first. All right. So let's find our domain. So what is our domain? It's gonna be, since we have a square root under here, that means we have to test it. We want to know when x minus 5 is greater than or equal to 0. So we get x is greater than or equal to 5. So what is our domain? Our domain is 5 to positive infinity, right? Lastly, what is our range? So we know for our graph, so in general it looks like this, right? But because we have plus 5, it's going to shift our graph 5 units, right? So, and technically, since it's plus 5, that means or minus 5 is going to be somewhere over here, right? But we're not worrying about the domain. We're worrying about the range right now. So it's going to be from 5, and then it's just going to keep going up, okay? So what is our domain? Our domain is 5 to positive infinity as well. Okay, so we're going to keep that in mind when we solve for our functions, right? So let's continue. So now we want to find f inverse of x. In order to do that, we have to follow the steps. So I'm going to change f of x into y. Okay, then we're going to interchange x and y. Now we're going to solve for y. So again, when we want to solve for radicals, we have to, when we want to solve for the variable under a radical, we have to isolate it so we can get rid of the radical. So this is x minus 5 equals the square root x or y minus 5. Right? And then over here, our index is equal to 2. Okay, since it's 2, what we're going to do is we're going to square both sides. Again, we don't have to expand this. We can just keep it as is, and this becomes y minus 5. So over here we have y is equal to 5 plus x minus 5 quantity squared. Again, remember, what are we looking for? We're looking for f inverse. So this becomes f inverse of x is equal to 5 plus x minus 5 quantity squared, right? Again, looking at here, like just looking straight at this, there is no restriction on a domain because this is a polynomial. There's no fractions, there's no rationals, okay? So looking right at it, it would be negative infinity to infinity. However, we do have restrictions because of this up here. And keep note that for an inverse function property, these are inverses for all of the x in the domain of G, and for all the x, and for all of the x in the domain of F. So they have to be able to map to each other. Right? So if I put negative infinity into infinity, then if I put, and since this would represent the range, then if I put if I put 0, then it wouldn't satisfy our original equation, and that's not good. Right? So remember that f inverse, so its domain is our range of f. So what is the domain here? Our domain is 5 to infinity. Right? And that is how you find the inverse functions and its domains for radicals. So if you guys have any questions, please let me know. I know this um, finding domain and range can be tough, especially when there's restrictions involved. So yeah, email me, put it on the discussion board. But if I don't hear from you guys, I guess I'll talk to you tomorrow. Bye.